What we're going to do is continue graphing logs. We're going to be looking at the horizontal shift. So if we look at each one of the logs that we're going to be graphing, we notice that there's parentheses, and that shifts the graph horizontally, either to the right or to the left. How we find our vertical asymptote is whatever gives us 0 inside the parentheses. So x is going to be equal to h. We could kind of think of it as the opposite of whatever's inside the parentheses. We're going to use the same 1 and b values, except because of our horizontal shift, those will shift a little bit too. So the first thing that we're going to do is we're going to find our vertical asymptote. So for the vertical asymptote, it's whatever gives us 0 inside. So in this case, it would be 2. Then what we're going to do is we're going to come up with our table of values. And with the table of values, what we're going to do is we're going to use the numbers 1 and b. So what gives us a 1 here would be a 3. And what gives us a b value, in this case it's 2, would be a 4. So 3 minus 2 is 1, and we know the log of 1 is 0. 4 minus 2 is 2. Whenever the bases are the same, it becomes 1. So when we're graphing this, what we're going to do is we are going to plot our vertical asymptote. So our vertical asymptote is going to be 2. So we're going to draw a vertical asymptote at 2. And then with our graph, we have 3, 0, and we have 4, 1. And this right here is going to be our graph. Now, we're also going to find the domain and range. Domain is always going to be based off of our asymptote. So in this case, it becomes 2, infinity. And our range is always going to be the same. We see that the line goes up and it goes down, so it's going to be negative infinity to infinity. So looking at our second one, our vertical asymptote is what gives us 0 inside the parenthesis. And so in this case, it's negative 1. Then what we're going to do is we're going to come up with the table of values. And our first number is always 1. So in this case, if we plug in a 0, 0 plus 1 is 1. And we know the log of 1 is 0. Times 2 is still 0. Then what we're going to do is try to figure out what gives us a half. So we're going to put negative 1/2. Negative a half plus 1 is a half. When the bases are the same, it becomes 1. Since there's a 2 in the front, 2 times 1 gives us a 2. So when we're graphing this, we have our vertical asymptote at negative 1. We have 0, 0. We have negative a half and 2. And here we have our log. When we're trying to figure out our domain and range, we know that our domain is going to start at the asymptote, which is negative 1 to infinity. And then our range is going to be negative infinity to infinity. Now, if we're looking at the third one, our vertical asymptote is always what gives us 0 inside. So that would be negative 2. We're going to come up with our table of values. And so our table of values, our first one is always 1. So what gives us a 1 here is a negative 1. Negative 1 plus 2 is 1. The log of 1 is 0. And we could kind of think of this as a linear equation. When we plug in 0, 2 times 0 minus 1 gives us negative 1. Now looking at this, our base is 3. So what gives us a 3 would be a 1. 1 plus 2 is 3. When the bases are the same, it becomes 1. So 2 times 1 minus 1 gives us a 1. We have our vertical asymptote at negative 2. We have our points at negative 1, and 1, 1. And so when we're trying to figure out our domain, it always starts at our asymptote, which is -2. And then our range goes from -infinity to infinity. So if we're looking at the next ones, first thing is our vertical asymptote. So we see that our vertical asymptote is x equals 0. Notice there's no parentheses, so it's similar to what we did last time. Our table of values, we're going to pick 1 because the log of 1 is always 0. And we're going to pick 1/4 because our base is 1/4. And when the bases are the same, it becomes 1. So we have our vertical asymptote at 0. And then when we plot our points, we have 1, 0, and 1/4 and 1. And so our domain always starts at our asymptote. So that would be 0 to infinity. And our range in this case is always going to be the same, -infinity to infinity. So looking at letter E, once again, we're starting off with our vertical asymptote, and that would be x is equal to 1. It's whatever gives us 0 inside the parenthesis. Our table of values, we start off with whatever gives us a 1. So what gives us a 1 here is a 2. 2 minus 1 is 1. The log of 1 is always 0. Then what we're going to do is we're going to figure out our base. It doesn't give us a base, so that would be a base 10. So 11 minus 1 is 10. Whenever the bases are the same, it becomes 1. And what I'm going to do is I'm going to go by 3s. So 3, 6, 9, and 12. My vertical asymptote is at 1. And then what I have is 2, 0, and I have 11 and 1. Domain, once again, starts at the asymptote. So that would be 1, infinity. And then our range is always the same. It goes up and it goes down. So -infinity to infinity. Now for our last one. First thing that we're going to do is find our vertical asymptote. And we see that our vertical asymptote is whatever gives us 0 inside. So that would be x equals -1. With our table of values, we're always looking for 1 because 1 gives us a 0. So in this case, if we plug in a 0, 0 plus 1 is 1. And so then what we have is the log of 1 is 0 minus 2 is -2. Next number we want is a third. So in order to get a third, it's going to be -2/3 because -2/3 plus 1 is 1/3. When the bases are the same, it's 1. 1 minus 2 is -1. So we have our vertical asymptote at -1. We have our 0, -2. We have our -2/3 and -1. And then what we do is we draw our graph. So our domain starts at -1 and it goes to infinity. And then our range goes from -infinity to infinity.